Hello, this is Brett from Survival Comms. Today we're going to take this DC motor and we're going to set it up as a reversible genset for a scale model. This project is a brainchild of my friend and fellow YouTuber Jim Bollinger from DoRite Fabrication, who has an awesome channel. I mean, if you're a homesteader or you're a do-it-yourselfer, you really need to check out his channel. He's got some fantastic content. And he's going to be posting videos of the entire project when it's complete, but I'm going to go ahead and show you right now what we're working with. Okay, the heart of our scale genset is going to be the generator, of course, which we're going to use a small DC motor. The DC motor is going to be mounted in a fixture, and it's going to be driven with a pulley off of the steam engine. Okay, the load for the scale genset is going to be an LED. Now, remember, an LED will only illuminate in one direction, which normally wouldn't be a problem, but the scale steam engine actually has a reversing valve, and the reversing valve would actually change the polarity of the output. So Jim wanted to ensure that this LED would illuminate whether it's in forward or reverse. So we were talking about how to make that work, and we came up with the idea of just using a simple bridge rectifier, a full wave rectifier. Okay, I've made a little diagram to talk about what we're working with here. What we've got here is we'll start with just a standard diode right here, schematic diagram for a diode, and it consists of two parts, an anode and a cathode, and it allows current to flow in one direction and inhibits the flow of current in opposite direction. Okay, so it's like a one-way valve if you think about that. If you look at a standard diode package, what you'll do is you'll see the cathode is marked by a black band generally, and the anode is unmarked. When you're installing them in a circuit, you want to put your positive on one side and your negative on the opposite. And on an LED here, we look at a standard LED package here, your anode, when it's brand new, generally has a longer lead than the cathode. But if you're cutting them out of something or scavenging them out of something, what you can do is you can look in the globe, and the portion of it that has the longer or has more material in it, it's shaped like this, is the cathode, and the smaller one is the anode. And another way is if you look at the top of the globe, you'll see there's a flat section at the base of it, and that'll indicate the cathode. Now, we look right here at our full wave bridge rectifier. And what we have is, normally in a power supply you'll have a transformer. You'll feed the transformer output into the rectifier, and what you do is you get DC out at these points here. So when you feed the AC in, you feed it at cathode to anode junctions, and then where it's cathode to cathode, it's going to be positive DC out, and anode to anode is going to be negative DC out. So theoretically, in our project we're going to work on today, when you feed the motor's input or the scale genset's input into these positions here, whenever you turn the reversing valve on and it reverses the polarity, it's still going to have DC coming out without shifting its own polarity. So that's what we're using it for. Normally in a transformer type power supply, what it's doing is the transformer output is AC, it's fed into here, and it comes out as DC. Now, if you were to take these diodes and lay this out on a piece of perf board to build a rectifier like this, what you would do is you can see right here, you'd lay it out, and what you would do is you would tie in your anode to cathode, anode to cathode here, and then that's where you'd feed your AC at these 2 points on your board right here. And then you would have your DC out when you go cathode to cathode. It's going to give you your positive DC, and then anode to anode is going to give your negative DC. Yes, there are integrated circuit variations of our rectifier we're going to make, but what fun would that be? We're going to start out by just merely threading our diodes through our perf board. Now you can see once we've placed our diodes on the perf board, I've interlaced them to essentially recreate circuit traces. Now it's just time to solder it together. Okay, we've got our small rectifier done now, and this is where we're going to feed it from, right here and right here, because that's anode to cathode and anode to cathode, so that's where we're going to feed either our AC source or, in our case, the little DC motor, which is going to be the scale genset. On this right here is cathode to cathode, so that's going to provide positive polarity direct current. And this is going to be anode to anode, which is going to provide negative polarity direct current. So let's go ahead and put our LED in. And there's where our LED is mounted, right on top. Okay, now we've got our board completed and hooked up to our simulated genset here. And as we spin it, you can see flashes. That's going forward. That's going backwards. Okay, let's try spinning it with a motor. Forward and backwards. Well, now Jim can go ahead and get his Christmas presents made for his family, and I encourage you to go over there and check out his channel. He's got all kinds of really great content on there, and I hope this helps. This is Brett from Survival Comms. Till next time.